Good morning, grade 8. Our new lesson today is called Data Distributions, chapter 10, lesson 3 in Algebra 1. Okay, today we're going to listen to words that it is popular to us. We have learned it from maybe grade 4 or 5, mean, median, mode, and range. Let's review them. The mean is the average of the values or the sum of the values in the set divided by the number of the values in the set. Again, the mean is the average of the data values or the sum of the values in the set divided by the number of the values in the set. Just wait 1 minute. So the median is the middle value when the values are in numerical order, or the mean of two middle numbers if there are an even number of values. The mode is the value or values that occur most often, repeated mean. A dataset may have one mode or more than one mode. If no value occurs more often than another, the dataset has no mode. The range of a set of data is the difference between the greatest and least values in the set. The difference I subtract between the greatest and the least values in the set. The range is one measure of the spread of a data set. Okay, example 1. Finding mean, median, mode, and range of a data set. The numbers of hours Isaac did homework on 6 days are. So, there is a boy called Isaac. He's doing his homework and he is recording how many hours he is doing his homework on 6 days. The first day is 6 hours, 8 hours, 4 hours, 6, 5, and 4. Find the mean, median, mode, and range. So, the first step, write the data in numerical order. Numerical order means from least to greatest. From least to greatest. So the least number is 3, then comes 4, and 4 is repeated again, then 5, then 6, then 8. Okay, mean. Let's go back and see the definition of mean. Average of the data values or the sum of the values in the set divided by the number of values in the set. So the mean, I'm going to add all the numbers and divide by the numbers of value, like 3 plus 4 plus 4 plus 5 plus 6 plus 8. Divide by what? Divide by how many numbers do I have? 1, 2, 3, 4, 5, 6. Okay, girls, I will divide by how many numbers do I have? 1, 2, 3, 4, 5, 6. So I'm going to add first the numerator. 3 plus 4, 7, 7 plus 4, 11, 11 and 5, 16, 16 and 6, 12, 16 and 6, 22, 22 and 8, 30. Over 6, so it is equal to 5. Okay, add all the values and divide by the number of values. So simple. Add all the values and divide by the number of values. Okay, what about the median? What about the median? Median, I have two options. Whether the number of values is an odd number or the number of values is an even number. Okay, let me do something here. Okay, if I will modify something in the set, like 3, 4, 4, 5, 6, and 8. And let me repeat another number, which is, for example, 8. No, let's be 5. Okay, how many numbers do I have? 1, 2, 3, 4, 5, 6, 7. I have 7 values. I have 7 numbers. So to calculate the median, do like this. Cancel number from here and number from here. Number from the left corresponding to number from the right. Number from the left corresponding to number from the right. Left for me what here? A number. The middle number here is called median. The middle number here is called what? Is called median. I have only one number. I have only one middle number. Why? Because I have a set of odd numbers. 1, 2, 3, 4, 5, 6, 7. When I cancel one from here and here, and one from here and here, and one from here and here, left for me in the middle only one number. Let's repeat the set if I have even numbers, like the one in the book. Okay, girls? So if I want to calculate the median, do like this. Cancel one from here and one from here, outside, and then one from left and one from right. If I cancel one from here and one from here, nothing will be in the middle. No, I cannot. So left for me what here? 2 numbers. There will be one number or 2 numbers. Nothing than this. 1 or 2. There can be 3 numbers, because if there will be 3 numbers, you will cancel one from the right and one from the left, and there will be one in the middle. So you have 2 choices, that 1 in the middle here or 2 in the middle here. Now, what if I have 2 in the middle? Shall I write the median is 4 and 5? No, I will not write the median is 4 and 5. I will write the median is 4 plus 5 over 2. Why 2? Because they are 2 numbers, 4 and 5. So it is equal to 9 over 2. 9 over 2 is 4.5. Okay, girls? So if in the middle there are 2 numbers, I will add the 2 numbers over 2. Over 2. And I divide. Okay, girls? Let's go here to the book. Okay. So the median here is 4 and 5 after crossing from left and right. One from here and one from here. One from here and one from here. What is left? 2 numbers, 4 and 5. There is an even number of values. Find the mean of the 2 middle numbers. Mean is average. The word mean is the same like the word average. Average mean. I'm going to add the numbers and divide by the number of values, like 4 plus 5 over 2. I will do the same step here. I will do the same step here. Add all the values and divide by the number of values. Add all the values and divide by the number of values. So all the values are 4 and 5. Divide by the number of values, they are 2. So 4 plus 5 equals 9. Divide by 2 is 4.5. Mode is the number that occurs most often. Occurs most often, repeated a lot. So what do you think the number that is repeated a lot? 4. 4 is repeated. There can be 1 mode, 2 modes, or no modes. The range is the difference between the greatest and the least. The greatest here is 8 and the least is 3. So 8 minus 3 equals 5. Okay, girls, let's watch here a movie, a video.
Well, suppose we have lots and lots of data. We have to somehow figure out a way to analyze it, which really involves seeing how the data is distributed. Well, actually seeing how the data is distributed is kind of tantamount to asking, can we take all that data, all that information, potentially tons of data, and say, well, we're not going to carry it around with us. Can we sort of distill it down to one or two or a couple of values that really capture what we think of as the measure of central tendency of that collection of data? Well, how is that possible? How can we take lots and lots of values and sort of boil them down to just one? Well, in some sense, this notion of measure of central tendency is a way of doing just that, getting all the data down to a representative number that tries to capture the spirit of the data. Let's take a look at an example so you can see this happening in real life. All right, so there are 6 employees at a particular company, and their years employed at the company are given by 10 years, 6 years, 2, 3, 1, and 2. I want to figure out what is sort of the measure of central tendency. Well, there are actually several different ways that we can think about measuring this. There's the mean, the median, the mode, and then the range. So let's talk about these. The mean is the kind of average that you normally think about when you're trying to figure out your grades. That's when you add up all the values and divide by the total number of values you have. The median, in some sense, is the middle value. It's that value that's right in the center of the data if you were to actually order the data from the smallest to the largest. The mode is the most popular data, so that particular datum that actually appears the most often. And the range is in some sense the measure of the spread, how far spread things are, by taking the highest point and subtracting off the lowest point and seeing what that range really is. So let's compute all 4 of these measures of central tendency for this particular data set. So for this data set, in years employment, we have 10, 6, 2, 3, 1, and 2. Okay, so the first thing we want to do is compute the mean. So the mean is just the usual average that we're used to seeing. How do we do that? Well, we add up all these values. So we take 10 and 6, that's 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24. And we divide by the total number we have, which is 6. And so we see the mean, this particular measure of central tendency, is 4. The average is 4. What about the median? Well, to compute the median, what we do is we take this list and we order them, or the numbers from smallest to largest, which I'm doing right now live. There we go. I think we've got them all. And now I look for the number that's right in the center. Well, you'll notice that we have an even number. So since we have an even number, what we do is we take the 2 numbers that flank the actual center and we average those 2. So in this case, we take the 2 and the 3 and we average those 2 by finding their mean. And so we add them up and divide by 2 and we'd see 2.5. And so we see 2.5. Now what about the mode? Well, the mode represents the most popular response. So the response that appears the most often, which you can see in this case, is 2. So in fact, we see that the mode equals 2. And what about the range? Well, for the range, we just take the highest value, the lowest value, we subtract, and so we see 10 minus 1, and we get 9. So you can see that all these values represent different measures of central tendency. And when you look at them, the mean, the median, the mode, the range, they're all different numbers, but in some sense, they do in fact capture all of this data. And that is the point of measures of central tendency, capturing the data. Let's take a look at another example, just so you can practice getting this notion of measures of central tendency. All right, here we go. So this is the low temperature over 5 days in December. We have 5 13, 20, 17, and 10 degrees. And I like to do, for each of these, I like to find the mean, median, mode, and range. All right, so what are we going to do here? Well, first of all, let's just take the data, and we can organize it a little bit. So if we take the data, let's just begin by organizing it. For the mean, we just add all the numbers up, and we divide by 1, 2, 3, 4, 5. So if we add all the numbers up, we see 18, 38, and 27. We get 65. So we have 65 divided by the total number of data points, which is 5. And so we see a mean of 13. So 13 degrees low temperature. All right, now what's the median? Well, the median is going to be what we see if we now order these things from lowest to highest. So we just do that little game to play. Let's go. We're sort of great. Now, there's an odd number of data points, so there will be a middle term. In this case, it's 13, and so that in fact is going to be the median. All right. What about the mode? Mode's the most popular. But look, it's tied. There's only one of each temperature, and so in fact, in that case, we say there is no mode. No mode. No mode. No mode. And what's the range? It's just the difference between the largest and the smallest. And so we see 20 minus 5, and we see 15. Again, these are all measures of central tendency that allow us to understand how the data is spread out, clustered together, and where that average is.
Okay, girls, let's go back to the book here. Okay, we have another word that I think also you have read before. It is called outlier. Outlier. What is outlier? Yes, Tara. What do you want, Tara? Okay. You didn't understand the range. Okay, I will repeat. Okay, the range. The range is the difference between the least number and the greatest number. If you are going to arrange the numbers from least to greatest, if you're going to put them in numerical order means from least to greatest. Like here in example 1, okay? Like here in example 1, you put the numbers here from least to greatest. The greatest is 8, the least is 3. So you're going to subtract 8 to make 8 minus 3. 8 minus 3 is 5. Okay, Tana? Okay. Outlier. A value that is very different from other values in a data set is called an outlier. A value that is very different from the other values in a data set is called an outlier. In the data set below, one value is much greater than the other values. For example, I will tell you, if we are in the winter and all the weather, if I will check the weather application in my mobile, I find that today the weather, the maximum degree is 12, tomorrow is 10, after tomorrow is 11, 13, and by the end of the week it will be 25. So 25 is different. 25 is outlier. We are in the winter and the weather is very cold, and the range of the average of the weather is 10, 11, 12 degrees, and now it is 25. So 25 is different from the values that we are checking. So outlier means is very different from the other values in a data set. Okay, let's go to the next page and I will read what the Tala wrote for me. Okay, welcome dear. So, determining the effects of outliers. Okay. Identify the outlier in the data set and determine how the outlier affects the mean, median, mode, and range of the data. Okay, here I have 7, 10, 54, 9, 12, 8, and 5. So what is different? So clear it is 54 because all the other numbers are 7, 5, 8, 12. They are in the same interval. Like yesterday we learned the intervals, they are all in the same interval. But 54 is very far. It is different from the other numbers. So first write the data in numerical order. 5, 7, 8, 9, 10, 12, 54. So the outlier is 54. Look for the value much greater or less than the rest. Okay, girls? So I'm going to calculate all median, mean, mode, and range with the outlier and without the outlier. With the outlier and without the outlier. So the first here on the left with the outlier. 5, 7, 8, 9, 10, 12, and 54. All my set is here. Over the number of values. I have 1, 2, 3, 4, 5, 6, 7 values. So I will write over 7. When I add all the numbers in the numerator and divide them by 7, it would be 50. The median. Cross 1 from here, 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 and 1 from here. So left is 9. So the median is 9. The mode. Do you find here any number that is repeated or occurs a lot? 5, 7, 8, 9, 10, 12, 54. No, there is no. So each value occurs once. So there is no mode. Range. Difference between the greatest and the least. The greatest is 54 and the least is 5. So 54 minus 5 is 49. I will do all the same steps, but without the outlier. Without the outlier. I will exclude the outlier from here. Okay, girls, I will exclude here the outlier as if it is not here. Okay, so 5 and 7 and 8 and 9 and 10 and 12. Over, I will not write over 7, of course, because I excluded one number. 1, so it will be over 6. If I add the numbers here, over the number, if I add the numbers in the numerators, and down in the denominator, I have the number of values, so I will get 8.5. The median. Now I have an even number, so the median will be, I will calculate it as the mean. 8 plus 9 over 2. 8 plus 9 over 2, so the median is 8.5. I will write it for you here. 8 plus 9, 8 plus 9 over 2. So it is equal to 17 over 2. So it is equal to 8.5. Okay. Mode. Also, there's no number that occurs a lot. Each value occurs once. The range is the difference between the greatest number and the least number. Of course, the greatest number was 54 and we excluded it. So the greatest number, we have a new one here that it is 12. So 12 minus 5 is 7. So you see the values here. The median here is 9. Here it is 8.5. No mode here and no mode here. The mean here is 15. The mean here is 8.5. The range here is 49. And the range here is 7. So what effects did the outlier do? The outlier increases the mean by 6.5. I'm going to subtract the old mean and the new mean. 15 minus 8.5 is 6.5. I'm going to subtract the old median and the new median. 9 minus 8.5 is 0.5. The mode, no mode before, no mode after. The range, I'm going to subtract 49 minus 7 is 42. So the outlier increases the mean by 6.5. Here I use the outlier. So all the values here are greater than the values here. All the values with the outlier is greater than the values without the outlier. So the outlier increases the mean by 6.5 and increases the median by 0.5 and the range by 42, and it has no effect on the mood. Has no effect on the mood. Why? Because in all cases there is no mood. This sentence, you have to know how to write it in this form. The outlier increases the mean by, because all the values with the outlier is more than the values without the outlier. Okay, so what you're going to do, you're going here to subtract the two numbers. We're going here to subtract the two numbers. Subtract the two numbers. Subtract the two numbers. Not here, here. Subtract the two numbers. Subtract, subtract, and subtract. Okay, girls?
Let's take a look at another application where we're being asked to find the mean, median, and mode.
Ready?
The following top 5 finishers of a marathon were 26, 24, 26, 29, and 49 years old. We're to find the mean, median, and mode with and without the oldest person's age. Okay, I'm going to read that again. We had 5 finishers, and their ages were 26, 24, 26, 29, and 49. 5 finishers, and these are their ages. Let's find the mean, the median, and the mode with and without the oldest person's age. Well, let's go ahead and let's do without. So what I'm going to do is I'm going to remove 49, of course, is the oldest age. I'm going to put 49 over here, and I want to find the mean, median, and mode. Well, recall that and notice what I need to do. I'm going to go ahead and arrange them in order from least to greatest. So we have 4 ages. What's the mean? If you add all 4 of these ages and divide by 4, you find that the mean age is 26.25. About 26 years old is the average age of these 4 finishers. What about the median? Well, remember the median?
She added the 4 numbers, 24 plus 26 plus 26 plus 29, and she divided by 4 the number of values.
Is that number in the middle? What's in the middle? The median is 26. We can see that right off. What about the mode? Which age occurs the most?
And here in the median, when she crossed from left and right, 2 numbers are left for me, 26 and 26. So 26 plus 26 over 2, so it will be 26.
Once again, we can see the mode is 26. Okay. Now, let's come over here and let's add this oldest person's age to our list of ages.
Which is
now we have 5. Let's compute the mean and the median and the mode. Okay? Well, if you add all 5 of these ages and this time divide by 5, you find that the mean, the average, is 30.8. Well, what about the median? Here I have 5, and the number that's in the middle is 26. And what about the mode? Which age occurs the most? 26 again. Now let's look at this. We have the same mode with and without the oldest person's age. We have the same median with and without the oldest person's age. But what about the mean? Did the mean change? Yes, it did. When we had the oldest, this was not part of our ages, the mean was 26.25. When we added the additional age, it increased to 30.8. The increase was 4.55 hundredths. What does that tell us? That tells us that the mean was the only one affected by adding this oldest age. There's a name for this number. It's called an outlier. An outlier is a value in a set that is very different from the other values. And we can see that 49 is much older than the other 4 marathoners. So sometimes when we add additional data, especially one that is very different, it can affect the mean, the median, or the mode. And in this case, the mean was affected.
Okay, girls, we're done from this part in this lesson today, and on Sunday we're going to continue this lesson. Any questions, girls? Any questions? Okay, see you on Sunday, and don't forget to answer. You have answered already your homework yesterday, right? Okay, thank you. Thank you, Tala, for interacting with me. Thank you so much, and see you on Sunday. Bye.